Welcome back. So we learned in the study of satellites around the Earth, the artificial satellites, man-made satellites, and we found that the velocity of the satellite is equal to capital Gm upon r plus h. Okay, so this is one relation that we had. The other relation is that the square of the time period of the satellite, whatever, is equal to 4 pi square r plus h whole cube divided by Gm, where h is the height of the satellite or the Earth. So this is okay. So from here, what we get is that square of the time period is proportional to the cube of the radius, which is almost in accordance with, or it is in accordance with, the Kepler's third law. Okay. Now, if we have the satellite very close to the Earth's surface, then the time period turns out to be 85 minutes, and we can see that if the time period we make 24 hours, which is in consonance with the time period of revolution of the Earth about its own axis, which is also 24 hours. So the satellite path we choose in the equatorial plane. If the equator is there, then North Pole, South Pole, and the satellite goes like this. So whether in the northern hemisphere or in the southern hemisphere, if there is an observer anywhere stationed at any point, we'll find that this satellite is at rest with respect to its location, and this we see that r plus h whole cube is equal to t square gm. From this relation I can write t square gm upon 4 pi square, which gives r plus h is equal to t square gm upon 4 pi square raised to the power of 1 by 3. Okay, so this is the relation that we have for any satellite, for that matter. So all we have to do is we have to choose the value of t as equal to 24 hours, that 24 into 60 into 60 seconds, etc. And this satellite to an observer will appear, because the Earth is moving from east to west and this satellite is also moving in the same way, so it appears to be parked, okay, stationed at a point on the equatorial plane of the Earth. Well, if we work out the things, substitute the values which are known to us, capital G m t square, 4 pi square, etc., then h can be calculated to be 35,800 kilometers. 35,800 kilometers, which is quite high up the surface of the Earth. The h is very, very large as compared to the radius of the Earth, which is 6,400 kilometers. Okay, so this satellite being parked, being known to us, what we can do is that we can use it as a communication satellite. Communication satellite, I mean that how data can be reflected back, how the data can be fed to this geostationary satellite and they can be taken back. Here I would like to talk to you about the radio waves, which are basically means of communication in the beginning, and that was 2 megahertz to 10 megahertz. 2 megahertz and 10 megahertz, I will just calculate it out to let you have an idea, since in when we learn about the waves, then we find that n lambda or nu lambda, where nu is the frequency and lambda is the wavelength, this is equal to for the electromagnetic waves, which are nothing but the light waves. Light waves are also electromagnetic. So many times EM waves, E by M. Electromagnetic waves, the speed is 3 into 10 to the power 8 meter per second. So by using this relation, when the frequency is 2 into 10 to the power 6 hertz, which is 2 megahertz, we calculate this out to be, the value of the lambda is 150 meters. And that corresponding to 10 megahertz turns out to be equal to 30 meters. These are long wavelengths. Okay. Now, it was found in the beginning the communication by radio waves took place in the line of sight, and there were reflectors, there were repeaters, etc. Then it was found that if powerful waves with energy of these magnitudes, they are modulated. Initially there was amplitude modulation, then FM also came, AM, FM, etc., etc. There are so many means of communication. I am not going into those details. There will be occasion to discuss them when we discuss the communications part, telecommunications part. So this is the kind of a telecommunication. So these waves got reflected oblique scattered, okay, back to the earth by ionosphere. Ionosphere is a layer of ions over and above at the surface of the earth, several kilometers above, and there are ions, and those ions, they reflect or scatter back. Now, what is the basic idea about it? The idea is that if there is a wavelength less than 30 meters, or around that value, less than that, much less, maybe, what happens? It goes right through the ionosphere and the information is lost. It is never scattered back to the earth, because in this kind of a communication there used to be from the earth, it will go to the ionosphere, scattered back, then again reflected back, go to that ionosphere, and it could travel many hundreds of kilometers by this means. Now what happened was, now before I go into that, I will just ask you a very simple question, and that simple question is about glass. About glass. So tell me, what is glass? Glass is solid, liquid, or gaseous. So the beauty of the glass is that it is not a solid. It is a super cooled liquid. It does not mean that while from the molten form the glass comes to the solidified form, okay, then it becomes very cool to touch that. No, the temperature is the same, but the heat which is taken away from the glass to make it solidified, Because in fluids, the temperature is more. In gases, the temperature is the most. Okay? And in solids, the temperature is the least. The solid is transformed into liquids, liquids are transformed into gases. What is there is the distance between and the relations between the atoms or molecules which constitute the solid, liquid, gas, or solid and fluid. So if they, why do we call it a fluid? Because it can flow. Anything can flow, has got a viscosity. Okay? So glass is a viscous liquid. But glass is not a viscous liquid always. If the heat is extracted away from the glass and it is allowed to be extracted away slowly, then what happens is the crystallization of the glass. If you take the heat quickly, then the crystallization process does not happen, and randomly the atoms or molecules are fixed here and there. Now you see that in most of the modern buildings, we have glass panels, glass windows, and thick glasses, of course, which can withstand the weather and the windy things. But why it is so? Because inside a room, the heat is not able to enter, and also the heat is not able to leave. So what's heat? Heat is a form of what we call infrared radiations. The lambda is more for heat as compared to the visible light, and is much less for what we call the ultraviolet rays or waves. So the waves are reflected back by the glass. They are not allowed to go out, or they are not allowed to enter, and the and things which you, as you desire, they are maintained. Anyway, so what happened, that there are some people who try waves of larger frequencies. Modulation is the process by which the information is conveyed. These are only the waves are carriers, and the information is put on the carriers. All the information is carried by these carriers. So when the wavelength was decreased or the frequency was increased, it was found, and technically it was said that no, if it is out of this range, then there will be no reflection or scattering back from the ionosphere. Well, the story is there. To cut it short, then it was found that short waves, shorter waves in wavelength, they could also be reflected back. This was observed by the amateur radio club members. Then engineers paid respect to their claims. First of all, they said no, their claims are tall. But when they saw themselves and said yes, it is possible, it is happening. But we scientists, we objected. Nonsense. What are these engineers and the amateurs they are talking about? This cannot happen. The ionosphere will not be able to do that. But some of them, they said, let us do experiments, let us study, okay? And that way, the other way around, it was found that there is a layer which is known as Kennelly heaviside layer. I'm sorry, I'm taking some time away. Kennelly heavy side layer, much above the atmosphere, ionosphere, which is able to deal with these shorter wavelengths and that way. But look here, if the wavelengths are made shorter, more shorter than what were dealt by the Canary heaviside layer, for example, you want to have communication with the moon, of course they will not return back until they are reflected back by the surface of the moon, etc. So, and the power associated with the shorter wavelengths is more. What they wanted was that we should be able to send our data by some means, and that means happened to be the geostationary satellites. So we send the data is reflected, scattered back to the destination. It can be pointed, it can be scattered, all kinds of things we can do. So at 35,800 kilometers, the geostationary satellites are a means of communication that we can use in radio or data communication system. Okay, so next item, we take up the polar satellites, remote sensing, etc. Now the polar satellites are low altitude satellites which have a time period of about 100 minutes. They are made into the orbit at 5 to 800 kilometers above the surface of the earth, and as shown here, this is the plane in which this is the north pole and this is the south pole of the earth, and about that these satellites they travel, and they make many trips in a single day, 24 hours. Now what we can do is that we can fix cameras to deal with a certain purpose. When these cameras, they can study small strips every time, and therefore we can have a strip by strip view for the entire day. These cameras are high resolution cameras and high frequency waves. They carry the information either in analog form or in digital form. These days mostly in the digital form. All communication is taking place in the digital form. We will talk about the analog and digital systems of modulation and communication when we are dealing in the communications later on. High resolution data are sent to remote sensing stations on the earth, and they are connected to each other. The study centers, they almost they work in real time, because the trip that they make is of very short duration of time, because you know that C is equal to the electromagnetic speed or velocity in vacuum is 3 into 10 to the power of 8 meters per second. These satellites are used for remote sensing. They are used in meteorology, for weather studies, for many other things, and applications to study the environment around. Okay, there can be special purpose cameras and processing and the system, and you can have many kinds of applications. Maybe you can monitor the agriculture, you can monitor other things with the help of these remote sensing systems. The remote sensing is an important part, and this is obtained by polar satellites, etc. So the communication is satellite communication, in this case also in the case of geostationary satellites, where we can use those stations because they are stationed, so with respect to the observer, and we have the purpose of the satellites today like that. Okay. Now we are going to talk about what is known as weightlessness, which is physical also, and there is something other than that also. Okay, it's a matter of feeling. So what we have a mass, okay, and this mass experiences weight mg on the surface of the earth, and when this mass is put on a rigid body with support, then there are two forces which are acting on the mass. One is the downward gravitational force, and one is the reaction of the surface, which is due to the electromagnetic forces, and R is equal to mg, and we say that m is at rest. So this is one condition where we have a body put on a platform. The second situation is that of a spring balance kind of a situation, and in that we have a spring balance which is hanging from the ceiling, and we put a mass over here, so the force mg is applied on it, and this gives a reading as to how much is the weight, and from that we can find out as to what is the mass. When it is in the position of rest, as is seen here, then of course there is an extension in the spring, and as a result thereof there are this mg is equated by a force over here, and the two forces are equal and opposite, and the tension in the spring, also we could take a string also. In that case also there will be a kind of a small extension. So what happens? Now what we do is that we release the spring from the ceiling. So both its ends are now, there is no extension, they are relaxed, they are in the release position, and this spring, whatever small mass it has, and this mass m2 which was attached to the spring, both of them start going down with a acceleration due to gravity or the field that we have, g here also and g here also. So we can see that there is no force to hold back the mass, like we were doing earlier here, or like the surface. So reading in the spring balance will be equal to 0. Reading in the spring balance will be equal to 0, and there will be a kind of a free fall of the feeler. That feeler could be you, the feeler could be me, he, she, anybody. So what is the feeling? Feeling is that you feel that you are weightless, and this occurrence of feeling weightless is called weightlessness. In free fall, like say we are in a lift, and the string which is holding the lift, it is snapped, and then we go falling freely towards the earth. In satellites, okay, We have the Earth and we have a satellite going around the Earth. Okay. So what happens? That the satellite is moving in a certain plane with a certain speed or velocity, whatever you. So there has to be a centripetal acceleration. Each part of the satellite has a centripetal acceleration which is equal to g at that location, not the g at the surface of the Earth. So whatever is the gravitational field at that location, it is the centripetal force is being provided by the gravitation. Okay. So there is no field of gravity. If you are there, if I am there, you will not feel gravity. So there is no field of the gravity. That means there is weightlessness, and if I or you, whosoever is in the satellite, is detached from the main body of the satellite, then things will start floating. Okay, this is exactly what happens. And here I said, I repeat, that the gravity is used to provide the requisite centripetal force. So this is called the concept of weightlessness.